this video, I'm going to show you guys a sample assembly that could be similar to what you could be getting on the CSWA exam. So as long as you know the features and where to use them, then you should be fine doing any type of assembly that you could see on the exam. In this case, we have a car jack. I could share a few tips with you guys with regards to the assembly. First of all, read the question thoroughly because there are some information that is critical to assembling this part, the parts together that won't be shown in the picture. For example, like this face could be like related to this face or be mated to this face using a certain feature that you might not see in the picture, but it will be described in these steps. So you want to make sure that you read it thoroughly. Another thing is each part. So you're going to get the parts for these assemblies already given to you. You're not going to have to make them. They will be given to you as a compressed folder. So you just have to, or as a file, you just have to unzip it and then start doing your assembly. But each part have a name already assigned to it. So based on that, you will make your assembly. So if you go to step 1, you can see that it says insert the base as the base part of the assembly. And if I go here, so what you want to do is come up to SolidWorks, press the home button, make an assembly. Now in here, you can come up here and insert component. And so like I mentioned before, each part has its own name. So when you're reading the question, it says insert the base part. What you want to do is make sure that you're selecting the part with the correct name. So first step, we have to insert the base part. But you're not just going to drop it anywhere, because if you do, the origin is going to be different from the origin of the question. So typically the origin of the question, unless otherwise stated, is the origin of the assembly. So if you click the part and then click the green button, click the OK button, the SolidWorks will automatically mate the origin of the part with the origin of the assembly. So what I mean by that is if you come up here and click on origin, you'll see that there is a blue dot. That's the origin of the part. And if you click on the origin of the assembly, it will also take you in the same spot as the last point. So that means that the part's origin is mated with the assembly origin, and that's a good thing, and that's what we want. So next step, we're going to have to insert. So if you want to do it quicker and if you want to save time, you can start assembling the parts as shown. You don't have to like skim over the steps, obviously, but if you want to make sure that you're saving time, then you can just start inserting parts and assembling them according to how the picture look. And then later on, if there's something that needs to be changed, you can do that. That's my way of doing it. You don't necessarily have to do this. You can go through each step, read it, and then do the assembling part. But this will save you some time. So just as an FYI. So if you go back here, we have two parts. We have the bottom linkage, which are these two, and we have the top linkage, which are these two. So here, so once you inserted the base, you can, depending on, I think it's easier if you insert the bottom linkages and then insert the pins, and then the top linkages, and then insert the pin, and then assembling the top part last. So let's do that. So we want to make sure that we have two bottom linkages here. And then the orientation of the part that you're inserting has to match the orientation of the part you're seeing. So if I zoom in, you see that the hollow part is facing up. So we want to make sure that that's the case. Yep. So we want two of this. There's two ways you can insert. You can have two of these in this assembly. The first step is obviously you do another insert component, and you click on the bottom linkage, and then you just drop it anywhere. Or a quick and easier way is if you click on this, it will highlight the bottom linkage. So click Control button, and then click the hold and drag this part. As you can see, it created a copy of it. So that's just another tip that could save you time. Next up, we have the pin. As you can see here, there are two pins that will be going through these holes, and they're going to be concentric to this part, and the base part. So let's insert two of that. So again, click on it, hold Control, drag, and drop. Okay, so let's start with this one. So there's two ways you can do the mating part as well. So the first way is click the surface, and then click where you want to mate the part, and then this window will pop up. And then if you know what these features do, then you can just click on any of them. So for example, I want this pin to be concentric to this hole. So click concentric, it will automatically do it for you. Or you can click mate and then do a bunch of them at the same time. So the next thing we want to do is we want to, just by looking at this, it looks like this, the face, the top surface of the pin is coincident with the surface. So click the top surface and then click the surface, and then it will automatically select coincident. Click OK. Next up, we want this hole to be concentric with the pin. Okay. Now, as you can see, this is not how we want it. So we want this face to be coincident with this face. See? Now, same thing here, concentric with this hole. Okay, this face with this face. And then if you notice on my cursor, there's the right click, and then there's a check mark on it. So once you're done mating the two parts, you can just click right click on your mouse button, and then it will automatically OK that for you. So you don't have to come up every time and then click OK here. So this hole with this part, concentric, and then what we want. So you can also, if you click a single time, it will select that face, and then it will try to mate it with another part that you're going to select next. Or you can click, hold, and then move the part. That way, it will not select the part. So if I click once, sorry, you see, it selected this face, and it wants me to select another face that they can mate it with. But if I clear here, and if I just click, hold, and drag, it will try to move the part where it's not constrained. So just another helpful tip. You can now click on this face, which we want it to be coincident with this surface. Okay. Now we kind of have the bottom part assembled. If you come up here, you can see that the bottom part is assembled now. Let's do the top part now. So insert component, we want to insert the top linkage. So if you come up here at the bottom, you want it, you can before dropping this onto the assembly, you can arrange it in a different orientation so that it matches the way you want it. So in the assembly, if I go back, I can show you. You see, this is the orientation that you want the top linkage to be. So a quick tip is you can also manipulate the part when dropped in the assembly, but that just makes it a lot harder. It's going to be time consuming, so you want to save as much time as possible. So quick advice is just that try to mimic the orientation of the assembly that's given. That will just make your life so much more easier. Now we want to duplicate this. We want 2 of this, and we want this black piece. Insert component, which is this part right here, the through pin. We want one here, and then another one right here. So again, click, hold Control, drag and drop, like I already mentioned. Now, let's come up here, do the same thing, click Mate. We want this cylinder to be concentric with this hole. Okay. And this surface to be concentric with this hole, this face. No, that was the wrong one. So as you can see, this is not how we want it. So the last mate that we selected is wrong. So let's just delete that. Now the part is, it can be moved freely. So this face has to be coincident with this face. Okay. Now, as you can see, this is the orientation that we wanted as. Perfect. Now, next, concentric with this part. Okay. Click this surface, or no. Okay. We want this surface to be coincident with this surface. Okay. Okay. Now, let's go back and have a look. As you can see, the top linkage is sitting in between. So the bottom linkage is in between the top linkage, and it's the holes of the top linkage is coincident with that through pin. So what I mean by that is, first of all, if we come up here, we have to make this hole concentric with this cylinder. Click OK. And this surface is coincident with this surface. Okay. Now, as you can see, the bottom linkage is in between the top linkage. Now, same thing can be done here. This with this, click right click, and then this surface is coincident with the surface. Okay, so click OK. Let's come up here and then, okay. So a few other things that could be useful I want to share with you guys. If you come up here on the Toolbar tab, you can select a quick access to some of the commands in SolidWorks. A few things that helps me is the standard view. It is where is it? There's a bunch of features that you can select from, but there are some that is very helpful to doing your CSWA exam. And second was the reference geometry. See, it comes up here. And the last one that is tools. So you see, instead of every time going here and then selecting a face that you would like to see, you have everything just as easy as click of a button away. from showing you guys the view that you want, for example, bottom, isometric, top, whatever. And this is the tools quick access. In here, there's a few things that is going to be helpful. The first one is the equations, and the second one is the measure, which is going to be very helpful. And on the left, we have the reference geometry. For example, if you want to insert a reference plane, this is very helpful if you're doing a part and not an assembly. So just a few helpful thing. Now, you kind of want to have it assembled the way that is shown on the question. So now in here, you want to constrain the part from bottom up. So the less things we have moving, the better it will be for us to, the easier it will be for us to assemble the assembly. So as you can see, we have a rod coming in here. This is the rod. So that will be the next part that we're going to be doing. So if you come up here, through rod. So as I mentioned, if you drop this here, it will kind of make it a hassle to assemble in this way. You have to kind of like go back and forth between selecting the surface and then zooming back out. But you can come up here and kind of mimic the question. So the question is oriented in this way. So that's what we want to do. So in here, we have two things we want to, so let's click mate. We want this and this to be concentric. Again, we want the rod and now the second hole to be concentric. And we want this surface to be tangent with this surface. As you can see on the left, it says tangent. Okay, and you might wonder how I know it is tangent. It's given in the question. Here on detail B, it mentions that that surface is tangent with this surface, with this through pin. So you kind of have to go back and forth in the question to see the details, but it's just an easy way of checking the question from the pictures. Up next, we have the top part and the two pins again. So let's insert this part. See, this is not the way that it's going to be sitting on the assembly. So we want to rotate it like this. Okay. Now in here, let's insert the pins. So we have the pins already here. We can just click on one of them, hold Control, drag, and drop. As you can see, the top linkage holes on one side will be concentric with these holes in the pin on one side of them, and on the other side it will be the same thing. So these holes, this pin, and these holes will be all concentric. So another, oops, not that one. We need a pin, which is this one right here. So click mate, click this part, click the inside of the hole, and then okay. Now here you want to click the top surface and the surface concentric. Same thing on the other side. Okay. Now here we want it to be concentric with this part. Okay. This with this concentric. And as you do this, it will automatically adjust itself. And the last one is we want it to be concentric with this face. Okay, so now we kind of have the we have it assembled. And as you can see, it is movable. So you want it to be constrained. And the last piece of the puzzle is this. So you want to come up here, click mate, click the top surface, and then on the question, as you can see, the bottom surface is where you want it to be constrained with. You want it to be at distance. So when you click mate, it will automatically default as coincident, which is why you saw the assembly turn into a weird shape. So you want it to be a distance, and the distance is 297 millimeters. 297. Click OK. Now you can only pivot the part. So you want the part to be not movable. That's how you know that your assembly is done. So we want to come up here and see what we are missing. Okay, so I think it is not given, or maybe I'm not seeing it. Okay, here, see the top face and the top face of the top and bottom face of the base are parallel and separated by distance A. So what that means is this surface and this surface is parallel. Now you can't move the part. And even if you do, they stay parallel to each other. So that is how you assemble this part. And the last piece of the puzzle, the last question that they will ask you is they want the center of mass. So the center of mass can be found from the mass properties, which I showed you guys how to have it readily available on the top part. So if you click here, center of mass is this. And that's it. I hope this video helped you guys. If it did, give it a thumbs up. If you guys have any suggestions for the future videos, please leave it in the comment below. And have a good day.